Hello friends, in this lecture we are going to continue with the different market models of microgrids. So before moving on to the different market frameworks, we'll just see the supply and demand side players of the microgrid. So in the supply side, we have wholesale market and micro sources. That means if there is power deficiency inside the microgrid, it can be purchased from the wholesale market. So wholesale market acts as a supplier in that case, and micro sources, of course, are used for local generation demand balance inside the microgrid. So the microgrid operator takes the role of local balancer as well as the backfeeder. Backfeeder in the sense, if there is excess power inside the microgrid, that is excess generation is there. If excess generation is there compared to the local load, then that can be sold to the grid or that can be pumped to the grid. So microgrid operator acts as a backfeeder also. He acts as a local balancer also. Local generation demand balance is also taken care of by microgrid operator. Now, in the demand side, we have regular loads of the consumers, then demand side management, that means flexible loads are also included, then storage devices that support charging and discharging to balance the generation and demand. Then wholesale market acts as demand side, acts in the demand side also, because if there is excess generation, then the backfeeding has to be done. So in case of backfeeding, wholesale market acts as a load demand. Now we will move on to different frameworks of microgrid markets or market frameworks inside the microgrid. The first one is a DSO monopoly model. A DSO monopoly model has probably derived from a non-liberalized power industry or a industry where DSO is the single entity that owns the distribution grid, and also the retailer functions of selling electricity to end consumers is also done by the DSO. I mean, in this single player context, both integration and operation of DER units, that is micro generators, storage units, everything is DER units, right? DER units, the integration and operation of DER units are undertaken by the DSO, which means the technical and financial consequences of the microgrid conversion is DSO's sole responsibility. So if an existing distribution system is converted to microgrid by installing active energy sources by means of investment by the DSO as a single entity, then the whole technical and financial consequences of this conversion, this microgrid conversion program, is the sole responsibility of DSO, or these consequences are to the DSO only. So whether it is cash flow or technical feasibility, everything is under the management of DSO. Now, moving on to the second model, which is the prosumer consortium model. Prosumer consortium in the sense a consumer who owns local generation or who owns a micro generating unit, and he is producing as well as consuming. In that case, we call it as a prosumer. He can have a storage device, or he can have electric vehicles for V2G applications, vehicle to grid applications. In this model, this is found in regions with high retail electricity price. That is why they form a consortium, and install their own sources. And financial support should be high in such locations. In this case, single or multiple consumers will purchase and operate units, micro sources or generating units to minimize their electricity bill or maximize the sales revenue from the power export. Okay, now this type of microgrid has barriers. I mean, a lot of barriers set by the DSO. As by nature, the consortium tends to minimize the use of distribution grid, and may neglect the network constraints, because each entity is a stakeholder, and in the consortium itself, each prosumer is a stakeholder, so they work for their own revenue. So more than financial considerations, there should be technical considerations as well, but they may be neglected because of their profit motive. So here DSO has to intervene with strict guidelines on the technical feasibility side. Then in prosumer consortium, the distributed energy resources are smaller when compared to the DSO monopoly model, because in the DSO monopoly model, it is, I mean, the sources are formed or sources are installed by the investment of DSO, and it is single owned, right? It's not owned by local consumers. So they are normally big units, and their location will be in the substation itself. Here, that is not the case. It's distributed. It's distributed among different prosumers, and the size will be small. Now, moving on to the next model, which is the free or liberalized market model, where the microgrid is driven by various motives, that is economic, technical, or environmental. Environmental in the sense, if they consider carbon emission also as an objective, then that is one of the environmental objective. Then each stakeholder's profit motive, that is another objective, which is a economic objective, which is an economic objective or a financial objective. Now, what can be technical objectives? Technical objectives can be nodal voltages. They can be put as constraints also. It should not violate the limits, maximum and minimum limits. Then line flow constraints can be there. So these are technical constraints. So these models have both, not both, these models have three different objectives: economic, financial, and environmental objectives from various stakeholders. Here DSO is there. DSO may be the DSO can be the third party. Then consumer is there. Then prosumer will be there, the one who consumes and produces. A consumer, a normal consumer can only consume. Then the regulator would be there, who puts forward the policy guidelines. So a lot of stakeholders are there, and the market is completely free. And the daily operation decisions will be dependent on real-time negotiations. So real-time balancing should be done, and negotiations will be there between all the involved parties. It can include even ancillary services also. In this case, a microgrid central controller will be present to who takes the role of an energy retailer, who is simultaneously responsible for local balancing, then import of power, then export of power, then control and technical performance, maintenance, etc. So the microgrid central controller acts as a single third party. Okay, he acts as a third party. Of course, buyers and sellers are there, but he acts as a third party. The potential benefits of microgrid operation is distributed or split and directed to the recipients according to their involvement, the extent of their involvement. Now, moving on to the Next slide. Economic balancing scheme for a sample supply demand scenario. So here you can see one demand side player D and supply side player S. Now for the supply side player S, we know that for any of the stakeholders, the revenue minus expense is the profit. Now what is the revenue for the supplier? Revenue for the supplier is from the sale of energy to the demand side player. So cash flow is in the opposite direction, from the demand side player D to the supply side player S. So this is his revenue, the supplier's revenue. Then the cost of generation for the supplier is the expense. So revenue minus cost will give the profit of the player S, the supply side player S. Similar to this, we have a demand side player D also. He has benefit out of the energy received by him. I mean, the energy received by him will be used for different purposes. So based on that, he has a value for that energy, out of which he gets some benefits. So if this can be quantified in terms of money, then we can represent it in terms of currency, in rupees or dollars, maybe by using utility functions or some other approach. Anyway, that is not in the scope of this particular presentation, but this will be quantified. Now, expense for purchase. So expense for purchase in the sense demand side player D is purchasing energy from the supply side player S, and that is his expense. So this benefit minus his expense will give the player D's profit. Right. Now you can see here, this is the cost of generation, and this is the price at which the supplier sells power. Right. So this is his profit. This is supplier profit. Now this price is the expense for the demand side player, right? Demand side player. And after spending this much, spending in the sense this expense for purchase, he is making some benefit out of the energy received, which could be quantified in terms of money, right? So with that he gets some benefit. So the total benefit is the supplier benefit plus demand side players benefit. So that is the total benefit. So that is how value is created. The creation of value is based on the benefit that is I mean the supplier side benefit and the demand side benefit. So this is what is the economic balancing scheme or mechanism of demand and supply side players. Now coming to the minimization of the target value, cost should be minimized, right? Cost should be minimized. And the target value is defined as the self-supply cost minus export profit. What is export profit? If excess power is there in the microgrid, then the DSO pumps it to the grid, right? So the DSO gets some money for that. So this is export profit. But if there is no excess power, then this is not applicable. So that is why it is written here, if applicable. The second term is applicable only if excess power is there and if it is pumped to the grid. And the first term gives you the self-supply cost. Generation cost is there, right? Generation cost is there if the generation units are a separate entity with reference to the DSO, then the DSO has to purchase energy from the generation units, right? For that there is supply cost. So this is the supplier, this is the supply cost of the DSO. Okay, this is for the operator. So export profit and supply cost minus export profit. This is minimized. That is the objective. Okay. Now self-supply cost equals import energy cost. What is import energy cost? If there is energy deficiency inside the microgrid, then energy should be imported from the upstream grid. For that, some expense is there. Then micro source generation cost for self-supply. For local balancing, these generation units are generating energy. For that, cost of generation is there. That is what is the second term. Okay. Now, what is export profit? Export profit is export sales revenue, right? When the power is exported to the upstream grid, there is revenue. Then micro source generation cost for backfed energy. What is that? For local balancing, a proportion of energy from the microsource generation is used for local balancing, and the remaining is used for backfeeding to the upstream grid, right? This is what is the microsource generation cost for backfed energy. So export profit, which is substituted here, then self-supply cost, which is substituted here. You get the targeted value, and you minimize the targeted value for optimal energy management inside the microgrid. That is the objective function. Now we will move on to microgrid versus virtual power plant. We'll take a break and we'll continue in the next lecture. Thank you.